Hello, class. Today we are going to discuss section 7.2 and 7.4. Okay. If we can, we'll also discuss section 7.5. All right. 7.2 is rational exponents. That is, these are exponents that are fractions. Okay, let me give you an example. 9 to the half. That's a rational exponent. Okay, now to work with rational exponents, first we need a property. This is section 7.2. Okay, if I'm gonna work with this rational exponent, we need the following property, and that's this one: a to the 1 over n, note that's a fraction in the exponent, equals to the nth root of a. Okay, look, whenever we have a rational exponent, you see this denominator in the exponent. This denominator is the index in the radical. The base goes under is the radicand, but this index is the denominator in the exponent. Okay, so therefore this 2 is the index, this 2, and I'm going to call this 1 the power. I'll explain that later. Okay, but for now, this 2 becomes the index, the square root of 9. And we know what the square root of 9 is. The square root of 9 is 3. Okay? So therefore, this is a good property because it allows us to work with rational exponents. Here's another one. Consider this one. Look at this one. 27 raised to the 2/3. Rational exponents. You see this denominator? This denominator becomes the index. You see this numerator? This numerator is the power. Okay? This numerator in the rational exponent is the power. This becomes the index. And this 27 is the radicand. So this becomes the cube root of 27, and then the power raised to the second power. We always take care of the index before raising the power. Always. Okay? So therefore, this expression becomes, I'm going to take the cube root of 27. So this is, what is the cube root of 27? 3. I took care of the root now. I'm going to take care of the power of 2, which is 9. Yep. Okay. So there we have expressed a rational exponent using radicals. All right, here's another one. Let's do what they have here. Here's what they have. Okay, do some examples. Okay, here's a good one. Where's my eraser? Here it is. My eraser is right here. Okay. Here's some examples that they have. The book has. Watch this. The negative 27 over 8 raised to the 2/3. The negative 81 raised to the 3/4. Yep. What else? What else? Here's one. The negative 64 raised to the 5/6. Okay. All right. Don't forget, this denominator is the index and this numerator is the power, and we take care of the index first. But let's express this as a radical expression. So this becomes the cube root of the negative 27 divided by 8 and raised to the 2nd power. Can you take the cube root of a negative? The answer is yes, you can. The cube root of negative 27 over 8. I know that's going to be negative 3 over 2 raised to the 2nd power. The cube root of negative is possible. Yes, it is. Okay. It's negative 3 over 2. No, I took care of the root first. Now I'm going to take care of the power. This is the process, the way it is done. And so now let's raise negative 3 over 2 to the 2nd power, 9/4. Okay. You see this 3/4 in the power? This 3/4 is applied to 81. This 3/4 as a power is not applied to this negative. No. Whereas this 5/6 is applied to this negative 64. Yes, it is. This one is. This one does not apply to this negative because it's not within parentheses. Okay? So therefore, watch this. I'm going to take the 4th root of 81. I'm going to raise it to the 3rd power and then the negative. That's the way it's done. This power does not apply to this negative because you don't have parentheses. Okay? Now, let's take care of the 4th root of 81. What is the 4th root of 81? That's 3. Okay? So therefore this is negative, and then this is 3 raised to the 3rd power. Okay? And what's 3 to the 3rd power? 27, and it's negative, look. So this is negative 27. How about this one? Hey, listen to me. This power is applied to this negative 64 because negative 64 is within parentheses. So here, negative 64 is the radicand, and here 81 is the radicand, not this negative. Okay? So therefore this equals to the 6th root of negative 64, and then raised to the 5th power. And does anybody know what is the 6th root of negative 64? It doesn't exist. It does not exist, guys. Okay? So therefore, this does not exist. because you cannot take the sixth root of a negative. Whenever this index is even, this radicand cannot be negative, so this does not exist. Okay? All right. Okay. Right, so here's more. Here is more. Okay. Consider the following. Consider this. For example, here I'll do that one. I will do that one. I'm looking for good ones. Here are two good ones. This is negative 27 m to the third n to the sixth, and this is raised to the 2/3. Okay? And here's another one. Here is another one. Okay? Negative, and then parentheses, 32, a to the 10th, and this is raised to the 3/5. Okay? All right. So therefore, look at this base. This base is negative because this negative is within parentheses. This base is not negative because this negative is outside. Okay. So all of this for the first problem, all of this is the radicand. So this becomes the cube root, take care of the index first, of negative 27 m to the 6th, so m to the 3rd, m to the 3rd, n to the 6th, and this is raised to the 2/3. Okay? So I'm going to take the cube root of, actually, hold on, take this away, that's it. Okay, because this became the index and the 2 became the power. Yes. Okay, so let me take care of the cube root first. What is the cube root of negative 27? Negative 3. What is the cube root of m to the 3rd? M. What is the cube root of n to the 6th? N squared. And this raised to the 2nd power. And when you do that, raise this negative 3 to the 2nd power, that's 9m squared n to the 4th. Okay. How about this one? Note this negative is not within parentheses, so therefore this power does not apply to this negative. This power does apply to the negative because the negative is within parentheses, and all of this is, including the negative, is raised to the 2/3 power. But not this negative. This negative is outside. Okay, no problem. So we'll do this. We'll say the 5th root of 32 a to the 10th raised to the 3rd, and then now write the negative outside. Okay. So now let's take care of the 5th root of 32, which is 2. The 5th root of a to the 10th, which is a squared. And that's raised to the 3rd power, and this negative remains. Okay. And so therefore this equals to 2 to the 3rd is 8, a to the second cube is a to the sixth, and the negative remains, and that's the answer. Okay. Very good. Now, if your power is ever negative, not a problem. If your power is ever negative, that's not going to be a problem, guys. That is not a problem. For example, watch this. Okay, so if we ever have a negative exponent, that is not a problem. Watch this. Take, for example, negative 27, a to the third, and this is raised to the negative 2/3. Okay? That's not a problem, guys. Here's another one. Consider this one. Look at this one. Negative 1/81. Okay? And this is going to be raised to the negative 3/4. Okay? All right. Look. I'm gonna if you ever have negative exponents, that's not a problem. We can make this negative exponent positive by taking the reciprocal. That's not gonna change this negative. This negative will always remain because this negative doesn't bother us. This one does, okay? So we're gonna change this negative to positive by taking the reciprocal. Okay, no problem. So this becomes this. 1/-27. Note the negative remains because I'm just bringing it down. A to the third. And this is raised to the 2/3. And so now this became positive. And now I can apply the rule. This is the index, this is the power. So this becomes 1/, the cube root of what? Of all of this. Negative 27, a to the third. And this is raised to the second power. Okay. Which becomes what? 1/. The cube root of negative 27 is negative 3. The cube root of a to the third is a. And this is raised to the second power. And so therefore this becomes 1/, what's negative 3 squared? 9 a to the second. Okay. All right. How about this one? Well, what bothers us is this negative, not this one. Okay, this says the fraction is negative, but this is negative power. We're gonna make this negative power positive by taking the reciprocal, or you can just bring it up. Okay, so therefore this becomes the following: negative, you could say 1 times 81 raised to the positive 3/4. Now 1 you don't have to show. Okay, nope, it became positive. The negative remains. The 1 you have to show. Okay, so therefore this becomes the 4th root of 81 raised to the third, negative remains. Okay. And so therefore this becomes negative, and then the fourth root of 81. What is the fourth root of 81? Is that 3? 3. Raised to the third, which is negative 27. Okay. All right. Okay. All right. Consider the following. 2 more problems from this section, okay? Consider the following. We're just applying the rules, okay, to rational exponents. That's what we're doing. Consider this. Consider x to the 3/5 times x to the 2/3. Actually, 5/3. Okay, let's change that to 5/3. I did it backwards. X to the 5/3. X to the 2/3 divided by x to the 1/3. And then there's another one. Here's this one. Let's multiply t to the 5/8 times t to the 3/8 minus t to the negative 5/8. T to the 3/8 minus t to the negative 5/8. Okay? So here we're going to apply the product rule and the quotient rule. Okay? When you multiply, you add exponents. So therefore this becomes x to the 5/3 plus 2/3 is 7/3 divided by x to the 1/3. When you multiply, you add exponents. When you divide, you subtract exponents. So therefore, this becomes x to the 7/3 minus 1/3, which equals to x to the 6/3, which equals to x squared. Look at that. Okay. How about this one? Here we're going to distribute, and when we distribute, we multiply, and when we multiply, we add exponents. Okay? So therefore, this is going to become t to the 5/8 plus 3/8 minus t to the 5/8 minus 5/8. Because when you multiply, you add the powers. Okay? So therefore, this becomes t to the 8/8. This is t to the first minus t to the first. And this is t to the 0. And t to the first is just t minus, and t to the 0 is just 1. Okay? Very good. There you go. Okay? Gotta erase this, guys. Gotta erase this. Okay? This also has to go, guys. This has to go. Okay. All right, so that was section 7.2. let's go to section 7.4. And now we're gonna multiply radicals. Okay, guys? We are multiplying radicals, good people. To multiply radicals, we need the following property. All right, good people, watch this. To multiply radicals, we need this rule. The nth root of A times the nth root of B equals to the nth root of A times B. We need that rule. Once we understand that rule, we can multiply radicals. For example, consider the following. Consider this. Consider, for example, this is section 7.4, okay? Section 7.4, 7.4. Consider this example. Where is it? I just had it. I see it. -2, the cube root of 2. Times 5, the cube root of 12. Let's do it like this. For times, let's do 5, the cube root of 12. Okay. We can multiply this by using this property. Note, when you multiply, you keep the same index. You just multiply the radicands under the radical. Okay. So we can do that. First of all, this is outside and this is outside, so I'm going to multiply those two. That's -10. Now, I'm going to multiply the cube root of 2 times the cube root of 12. And that's going to be the cube root of what? Of 24. 2 times 12 is 24. Okay? And now, I'm going to simplify the cube root of 24. I'm looking for perfect cubes. Okay? Perfect cubes. So therefore, I'm going to say this is -10, the cube root of 8 times 3. 8 times 3 is 24, and 8 is a perfect cube. Okay? So therefore, I'll take the cube root of 8, which is 2. And that 2, when it comes out, gets multiplied times the -10. Okay? So therefore, -10 times the 2 that came out, and then the cube root of 3. But you can't leave it like that. You gotta multiply this 2 times -10. So this is -20, the cube root of 3. Okay? All right. Here's another one. Okay. Here is one more. Let's multiply the following. Okay, we can multiply that. Let's multiply this, look. Multiply 4, the square root of 2, times 3, the square root of 5, minus 2, the square root of 8, close it. All right. I've got to erase this, guys, because it's on my way. Okay, sorry about that. And so, let's multiply by distribution, and we're going to apply the rule. Okay? So by distribution, I'm gonna get, let me see, this 2 times the 3 is 12. The square root of what? 2 times the 5. The square root of 2 times the square root of 5 is the square root of 10. Minus. Okay. 4 times the 2 is 8. And the square root of 2 times the square root of 8 is the square root of 16. Okay? I can't leave it like that. I gotta simplify. Now, don't forget this 10 is 2 times 5. And you cannot take the square root of 2, and you can't take the square root of 5, so there's nothing you can do there. But the square root of 16 is 4. So therefore, this becomes, good class, this is 12, the square root of 10, minus a 4 comes out, multiply times 8, minus 32. There you go. Okay. So we are simplifying radicals. Yes, we are. Look at this other one. Try this one, for example. Try try 2 the square root of 3 plus 5 raised to the second power. Okay? If you're going to do this, my suggestion is write it out. Okay? So this says take this base and multiply the base by itself twice. So I'm going to write it twice. So therefore this equals to 2 the square root of 3 plus 5 times 2 the square root of 3 plus 5. Okay, and now we're going to FOIL. Okay, FOIL means first, outer, inner, last. So 2 the square root of 3 times 2 the square root of 3 is 4 the square root of 9. This is 4 the square root of 9. That's first. 2 the square root of 3 times 5, that's outer, is going to be 10 the square root of 3. That's outer. 2 the square root of 3 times 5 is 10 the square root of 3. That's outer. Inner. 5 times 2 the square root of 3 is what? That's 10 the square root of 3. That's going to be 10 the square root of 3. And then 5 times 5, which is last, is 25. Plus 25. And now I'm going to simplify. Okay? The square root of 9 is 3, and that gets multiplied times 4. So therefore, 3 times 4 is 12. Those two are like radicals, so we can add them. Okay? So what's 10 the square root of 3 plus 10 the square root of 3? That's going to be 20 the square root of 3, and then plus 25. If you take 12 plus 25, what do you get? You get 37 plus 20, the square root of 3, and there's nothing else you can do. Okay? All right. That was beautiful. Okay? So here we're multiplying radicals. We're multiplying radicals and we're simplifying radicals. Good class? Yes, we are. And all because of this little rule. Look. Yes, it's because of that little rule. Okay. Okay. There's this rule. Okay. Now, suppose we have multiplied radicals. Okay. Now let's divide radicals. For example, let us take the square root of 3 divided by the square root of 2. Okay? All right. Guys, when we divide radicals, we just have to make sure that we do not end up with a radical in the denominator. No radicals in the denominator, okay? We also have to make sure that there are no fractions in the radicand. We also have to make sure that every time we can simplify, we must. Okay? All right. So here, we cannot end up with this radical in the denominator. No, because it's not allowed. So, to get rid of this radical in the denominator, you gotta create these two into something you love. Okay? You have to make this into a perfect square. We love perfect squares, okay? So that's what you need to do, okay? So look, how can I make this a perfect square? And it has to be done legally, okay? Let's look at multiples of 2's. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12. All of these are multiples of 2's, but the one we love is this one. We love that one because it's a perfect square. Not this one, not this one, not this one, not that one. 2 times 7 is 14. 2 times 8 is 16. Oh, that's another one. We also love this one. Because it's a perfect square. But you know what? I'm going to use this. I'm going to make this 2. I'm going to make it a 4. Because we love a perfect squares under the square root. Now, legally, how can I make this a 4? I can make it a 4 by doing this. If I multiply this by the square root of 2, that's going to become a 4 in the radicand. But if I'm going to do it legally, I got to multiply this also by a square root of 2. If I don't do that, then I am not doing it legally. Gotta use the rules. Okay. All right. My aim is so that the radicand becomes a 4. All right. So now this becomes the square root of 6 divided by the square root of 4, and I love that 4. Remember, we said no radicals in the denominator. That's what we said. And so therefore, what is the square root of 4? 2. So therefore, this is the square root of 6 divided by 2, and no more radicals in the denominator, and there are no fractions in the radicand, and we have simplified all the way. Okay? So, no radicals in the denominator. Okay? Not a problem. Let's do the next one. Here's another one. Watch this one. 7 over the square root of 18, a to the what? A to the third. Remember, if you're going to simplify this, you should have no radicals in the denominator. You should have no fractions in the radicand. And it must be in simplest form. Okay. All right. The first thing I'm going to do is I'm going to simplify this. Okay. 7 over. And I'm going to say this is the square root of, I'm looking for perfect squares. So that's 9 times 2. And that's a square times a. And I am assuming here that all variables are non-negative, okay? I'm gonna assume that they are non-negative. That way I don't have to worry about the absolute value, okay? Now I'm gonna take care of this. This becomes 7. The square root of 9 is 3. The square root of a squared is a. And a 2 remains inside. And an a. What's the problem here? The problem is that we have this radical in the denominator. It's a problem. Well, no problem. I'm gonna make this a perfect square, and I'm gonna make that a perfect square. This is gonna become a 4, and this is gonna become an a square, and I have to do it legally, okay? To do that, I'm gonna have to multiply this by 2 and by a, but if I do it to the denominator, I must also do it to the numerator. So therefore this becomes the square root of 2a. By the way, they call this rationalize the denominator. That's what they call it. So therefore this becomes 7 times the square root of 2a, and in the bottom we get 3a times the square root of 4a squared. Yep. And now a 2 is gonna come out, and it's gonna get multiplied times the 3, and a is gonna come out, and it's gonna get multiplied times a. So therefore, this becomes 7, the square root of 2a, divided by, a 2 comes out, times 3 is 6, and a comes out, times a is a squared. Can you simplify further? No. And we're done with that. So rationalize the denominator, okay? Do it again. Let's rationalize the denominator. A couple of more times and then we're done. And so watch this. Let's rationalize the following. Okay, when we say rationalize the denominator, what we mean is let's get rid of the radicals in the denominator. Yep. Okay. So, here, let's do that. let's say the square root of x minus the square root of 2 divided by 3 times the square root of x plus the square root of 2. Okay? Now, we need to get rid of radicals in the denominator. Okay? When we have a binomial, a radical binomial, radical and then two terms, look. To get rid of radicals in the denominator, you must multiply top and bottom by the conjugate of the denominator, guys. The conjugate of this denominator is gonna be the following. Just change the sign, okay? So this is gonna be 3, the square root of x, minus the square root of 2, times 3, the square root of x, minus the square root of 2, and that's how we get rid of radicals in the denominator when the denominator consists of a binomial, a radical binomial. Okay. And now we are going to FOIL. FOIL. Let's do the denominator first. The square root of 3, the square root of x times 3 the square root of x is 9 the square root of x squared. That's first. Outer. 3 the square root of x times negative the square root of 2 is going to be what? Negative 3 the square root of 2x. Because those two are conjugates, you'll notice that outer and inner will cancel. Watch. So that's first, that's outer. Let's go to inner. The square root of 2 times 3 the square root of x is going to be what? Plus 3 the square root of 2x. See? They cancel. This is inner. Last. The square root of 2 times negative the square root of 2 is negative the square root of 4. First, outer, inner, last. In the near future, when you multiply conjugates, you can just ignore outer and inner because they always cancel. How about the top? The top, they are not conjugates. And because they are not conjugates, outer and inner will not cancel. So the top, the square root of x times 3 the square root of x is going to be 3 the square root of x squared. Outer, the square root of x times negative square root of 2 is going to be negative square root of 2x. Inner, negative square root of 2 times 3 the square root of x is going to be negative 3 the square root of 2x. And last, negative square root of 2 times negative square root of 2 is going to be plus the square root of 4. In the denominator, because those two are conjugates, this one cancels that one. Yep, yes it does. They cancel. In the top, an x comes out. Let's do that. So this is 3 times x. 3x. You can combine those two because they are like radicals. there's a -1 there. -1 plus -3, what is that? -4, the square root of 2x, and then this is plus 2. In the denominator, this one cancels that one. And so therefore an x comes out, and of course we're assuming that all variables are non-negative. That way you don't have to worry about absolute value, the answer being the absolute value, okay? So the square root of x squared is just x. So this is 9x divided by 9x. Those two cancel, minus 2. And that's your answer, okay? All right, this was section 7.2 and 7.4, okay? Thank you very much, good class. I'll see you soon.